So in this problem here, we've been given the cosine ratio. It's negative, so we know that has to be on this side. It has to be on this side of the circle. Okay, so we know it's negative. But this is also, so if it's negative, we have to consider there's two quadrants that we can possibly put it in. In this question though, the quadrant is given. Okay, so we're given the quadrant here. So we know that it must reside in quadrant 3. Okay, and we can ignore the possibility that it could be in quadrant 2. Although cosine can be in quadrant 2, we're just going to say it's going to be in quadrant 3. So when we solve for this angle then, I can just draw. I'm going to first of all sketch it in. So I have about, this is about 38%. So we're going to say that it looks maybe somewhere around there. Okay, so that's going to be negative 0.385 to 1. That's our ratio. And then that angle that we're going to calculate here, so I do second cos and negative 0.385. Okay, so what I will always state is that the theta 1 is going to be from the calculator. Now this is not mathematical convention. This is what Mr. Lin does. I'm going to, when I say theta 1 is the angle from our calculator. So our calculator gives us 112.64 degrees. Okay, and we're going to do this using our arc cos. Okay, so I just want to get used to using this notation. So I'm going to, my input for my arc cos is going to be the ratio, and the output is the angle. We never put this into cosine. So the angle is 112.64 degrees. So that's my theta 1. The problem is theta 1 is in the wrong quadrant. I'm going to just do this in a different color. 112.64 degrees. Okay. So theta 1 actually is somewhere around here. And it's locating that position. That's 112.64 degrees. Now that's all my calculator is going to give me. That's all the help it's going to give me. I know it's in the wrong quadrant, but I know that the symmetry for cosine is horizontal symmetry, so I'm going to fold it across, and I know it's exactly right there. So to find out the location of that black point, this one right here, I just need to use symmetry. Well, I know that I can go 112.64 this way. I know I can find a reference angle, maybe use a reference angle. But I also know that this, since it's folding along the x-axis here, I know it's symmetrical across that line. So I know that if I go backwards, negative 112.64 degrees, I end up in the position that I want, in the black position. I can use that angle, or I can do 360 minus that. I'm going to use a positive version of that. And I'm going to use 200, so I'll write it down here, 360 minus theta 1. Okay, and that's going to give me the positive version of that angle, which is 247.36 degrees. And that's going to be my angle measured in that direction. Okay, so that is the standard. Both of these are correct. Negative 112 and 247.36. They both measure the same position. That black dot right there. One is a positive version, the other one is the negative version of that. But now, although we've been given cosine, we have to consider two quadrants. Because the quadrant is given, we only give the answer as one answer in one quadrant. So that's our answer right there. Okay, we ignore the fact that theta 1, we ignore theta 1 because it's in the wrong position. And again, positioning is the most important piece when we're talking about standard positioning.